Hey everyone, welcome to this week's video. Today I'll be explaining average piston speed. Now in my last video I was talking about Formula 1 engines and how the bore-to-stroke ratio was pretty high, and the reason for doing that was because you want to have a large bore and a small stroke so that you can keep your piston speed down because of flame propagation, the speed at which combustion can occur. So I'm going to explain calculating piston speed and how that works. Now, piston speed. So how are we going to calculate how fast that piston is moving inside of your cylinder? Well, we're going to get an average speed to make it a little bit easier. And so speed is a measure of distance for a given unit of time. So all we have to figure out is how far has this moved in a given unit of time? Well, let's use 1 revolution as our time limit. So up and down, how long does that take to happen, and how far did it travel within that? So our piston speed is going to be 2 times our stroke. The reason 2 times our stroke is because it's not only going to travel to the top of the cylinder, but it's also going to travel back down to the bottom of the cylinder in 1 revolution of the crank. So 2 times the stroke times the revolutions per second. We're going to get this in units of meters per second, and then you can convert it to whatever you're familiar with. So, revolutions per second. Now, on your little tachometer, you're going to be given revolutions per minute. So, when you're doing the math, you're going to want to remember to divide by 60 so that you get that into revolutions per second. So, for a Formula 1 car, here I just kind of drew a cylinder and went with some dimensions for a typical Formula 1 engine. So, a 40 millimeter stroke and a 100 millimeter bore. Now, these aren't exact, they're actually a little bit larger, but just to prove that it's kind of in the right ballpark, we want to find out the volume of this cylinder. So we've got pi r squared times h, pi r squared, that's your circle, times h, that's the height of the cylinder, so you get the volume of the cylinder. Pi times 0.05 meters squared, so 0.05 is going to be half of the diameter, so 50 millimeters. And then 0.04 coming from the 40 millimeters for the stroke. Okay, so that gives you 0.0003 meters cubed. You've got 8 cylinders, so multiply that by 8 to try and figure out the volume of the engine. So you got 0.0025 meters cubed. Convert that to liters, just move your decimal place over 3, and you have 2.5 liters. Well, we know that Formula 1 engines are 2.4 liters, so obviously these are larger than they are supposed to be, but point is, they're pretty close. A small difference in that, I mean, you drop 1 millimeter, it's going to make a pretty big difference in the overall volume because that number is squared. Okay, so let's find out the piston speed of a Formula 1 vehicle. So we've got 2 times the stroke, which was 40 millimeters, so 0.04 meters, times the speed, the amount of times that happens per second. So you've got 18,000, and we're just going to do it at red line because that's the most interesting number, and that'll be the maximum. So the red line for Formula 1 being 18,000, so 18,000 revolutions per minute. We want that in seconds, divided by 60 seconds in a minute. So then you get a number, when you multiply all that out, of 24 meters per second. So that piston inside of that cylinder is moving, if it were to be moving at a constant speed, it would be 53 miles per hour. That's pretty crazy to think about. So just as a comparison, I figured I'd throw my Integra in there. I thought it could compete with Formula 1 pretty well. So I have a B18 B1 engine. It's probably the greatest engine in the world in my car. Great for, oil leaks sometimes and burning oil and things like that. Anyways, other good things about it are, well, it's average piston speed. So we've got 2 times the stroke of my engine is 89 millimeters, and the red line is about 6,800. So do the math there, multiply those across, you get a speed of 20.2 meters per second, or 45 miles per hour. That really isn't too much different from a Formula 1 car. So you guys can see why I chose the vehicle I did for my daily driver. It's pretty much like a Formula 1 car, just driving around town. Alright, so let's get a little more crazy. Let's go with the Type R, and let's go with the craziest Type R, which has the B18C motor, and it's in the DB8 model. Now, I believe this is only in the Honda Integra, which is sold in Japan. I could be wrong, but I got these numbers from Wikipedia, so if you get angry, that's where they came from. So the Type R V18C engine has a stroke of 87.2 millimeters. That I'm pretty sure on. The rev limit, that kind of varies with the different engines thrown in the Type R. Some say 8200. I've seen 8700, but anyways, I saw on Wikipedia 8600, so that's the number I'm going to use. So when you multiply across 2 times 0.0872 times 8600 divided by 60, you get a piston speed of 25 meters per second. Yes, faster than a Formula One car. In fact, if you convert that over, 55.9 miles per hour. So another 2.9 miles per hour faster average piston speed than a Formula One car. So a Type R is pretty much the greatest car in the world. That's what we have discovered here. Actually, there's probably other cars that can match that. So, but anyways, Type R and S2000 would probably be better than that, if not around that. But anyways, a Type R can hang with an F1. That's what we learned from this. No, it really can't. But anyways, why do you think these numbers are so similar? I mean, why wouldn't Formula One just blow away the competition? Well, the problem is, when you have combustion, the speed of combustion is only so fast. You can only expand air so quickly. You can only have a flame travel through an air-fuel mixture so quickly. So basically, these cars, the F1, the Type R, they're pretty much reaching the limit of that flame speed, and so you can't really exceed that. Now, what Formula One wanted to do was have higher revolutions per minute, and in order to do that, they had to lower their bore, or their stroke, I apologize. Lower the stroke. So by lowering the stroke, you can lower your piston speed, get it to a reasonable speed, and then you can have higher RPMs. So, one thing I challenge you to do, find out what your engine stroke is, find out what your red line is, or your rev limit on your vehicle. Do the math, it's very simple. Just plug in 2 numbers and get the average piston speed of your vehicle. See if you are faster than my incredible Acura Integra with 45 mile per hour average piston speed. And also, if any of you have diesel vehicles or something like that, where the speed might be very slow, I'd like to see that as well. So just post in the comments, and have a little competition. Who's got the better average piston speed? That's what cars are all about. So yeah, just let me know in the comments, and thanks for watching.